Hi everyone, I am Letian. In this video, I will explain 2020 Kelantan Addmath Paper 2 question 9. So this question provides us with two circles with a radius of j. And the center of the circle is M and N. So we can label the radius in the diagram. This j. And also this is also radius j. From M to N is also a circle, so it's also radius j. Now let us look at part A. It asks us to find angle PMQ in terms of pi. To find angles, right, we can first try to make some triangles, because if we have triangles, then we can use the sine cos tangent to find the angle. Okay, so we need to add two lines. First line between P and Q, and then the second line over here between M and N. Now we have two triangles. The first triangle is the second triangle. And then we know the base of the triangle is j over 2, because this line in the middle cut M and N into half. This line, it cuts M and N into half. So the base of the triangle is j over 2, which is the half of the radius. Now let us redraw the triangle. A, this M, this P, and then we want to find the angle PMQ. Can label here theta. So if this is theta and also this side is also theta, we can say that angle PMQ is 2 theta. Angle PMQ is 2 theta, because the line between M and N actually cuts the angle PMQ into 2, so it's 2 theta. Now we have this triangle. We need to know the length of the triangle of two sides. This j, and the base is j over 2. We have the adjacent and we have the hypotenuse. We can use cos theta to find the angle. Cos theta is equal to adjacent over hypotenuse. Adjacent is j over 2. Hypotenuse is j. So theta is equal to arc cos half. Arc cos half is equal to 60 degrees. Remember, the question wants the answer in the form of pi, which means it wants it in the form of radian. So to find radian, take 60 degrees multiplied by pi divided by 180 degrees, which is pi over 3. Now we know theta equal to pi over 3. We can find angle PMQ. Angle PMQ is equal to 2 theta, so 2 times pi over 3 equal to 2 pi over 3. So this is the final answer for part A. Now let us move on to part B. Part B asks us to find, in terms of j or pi, the length of PQ. So let us redraw the triangles over here. One is PQ, M, this. So the question asks us to find the length of PQ. And in the lines over here, we can divide the PQ into half. So the upper triangle, here X, here also X, because the bottom and top is symmetrical. So PQ is divided exactly into 2. Hence, PQ is equal to 2X. Now, notice that this horizontal line over here and this vertical line over here it will form a 90-degree, a right angle triangle. And then we know the length of the radius, j, and here the base of the triangle, j/2. We can use the Pythagoras theorem to find the length of x. Pythagoras theorem is the formula a squared plus b squared equal to c squared, right? So in our case, x squared plus j/2 squared is equal to j squared. So x is equal to square root j squared minus j/2 square root. So x is equal to 3/2j. Now we have x, we need to find this PQ. PQ is equal to 2x. 2 multiplied by 3/2j is equal to 3j. So PQ is equal to 3j. Okay, now let us move on to part B2. Find the area of the shaded region. So this is the area of the shaded region. I've drawn some diagram over here for part C. As we can see, this is the area of the shaded region. We cannot find the area of the shaded region directly. So we can actually use this method. We can find the area of one complete circle and then we minus off the area of the part that's not shaded, this part. So it's over here. Let's say we take the area of one full shaded circle minus off the part that's not shaded, we'll be able to get back the area of the shaded region. Now, but there's another problem. We are still not able to find the shaded region for this one. How to find the area for this one? We can actually split this area further into two parts. We can split this area into area of a part of a circle, a slice of the circle. It becomes a equal to half r squared theta we can find. So let me draw over here. Sorry. Draw over here. Basically, this part that I've drawn is this one. So we can split it into this one, and also another one is this one. It's a segment of the shaded region. So we also want to find this part. Now we already is able to find the area of a slice of circle using this formula. And how about the segment of the circle? We need another way to find. So this is the way. This part we can use it to find the segment area. Basically, how it's done is by taking a slice of circle minus off the area of the triangle. This is a slice of circle, this area of the triangle. We take this one minus this one, we'll get the area of the segment. So if we can get the area of the segment, this part is area of segment, right? We can also find the area of this one because this one is simply area of the segment multiplied by 2, right? So after we get the area of this thing, we find the area, then we can add the area up with the area for this one. Then add this up, it will be area for this one. Okay, so let us get straight into the equation, like into the calculation. So the first thing, find the area of the segment. Area of segment. Area of the segment, we take the area of the slice. So notice this is also a center of the circle. And then the radius is J. To find area of a slice of circle, use half r squared theta. In this case, the r is J, half J squared, and the theta is theta as we have found previously over here, pi over 3. Because, let me show it over here. This is theta. This is also theta. Both sides are symmetrical. That's why we can use the angle over here, pi over 3. So theta, pi over 3. And then don't forget, area of the segment need to minus the area of the triangle over here. This one, area of the triangle, we can use formula half AB sine C. Let me write it out. This is area of triangle. This one is area of slice of the circle. So we substitute in the value. This is the A and this is the B. Both are radius J. And the angle is sine C, this is the angle C. A is J, B is J, and the angle C is over here, pi over 3. It's also pi over 3, same as our quadrant. This is pi over 3. This is also pi over 3. So sine pi over 3. So put into the calculator, we can get the area of the segment as this one, pi over 6 j squared minus 3 over 4 j squared. So this is the area of the segment. This one is area of segment. Now we have the area of the segment. You want to find the area of two segments. The area of the two segments, this one, because there's two, right? This is one segment, two segments. So we want area of two segments. So area of two segments is equal to 2 times pi over 6 j squared minus 3 over 4 j squared. Become pi over 3 j squared minus 3 over 2 j squared. Okay. Now we have area of two segments, which is this one. This is area of two segments. Then we need to find the area of this guy. This guy. To find this area of this guy is a slice of the circle. So use back A equal to half r squared theta. So area of this one, this is a slice of circle, is equal to half r squared theta. R is j squared. Theta is 2 pi over 3 because this angle PM and Q. So angle PMQ is 2 pi over 3. So substitute in theta 2 pi over 3 is equal to pi over 3 j square. Okay, now we have the area for this one and this one. We add them out to get this. So area of, let me draw this out. This is the center of the circle. Will be equal to this one plus the two segments. So this pi over 3j squared, pi over 3j squared plus area of two segments. This area of two segments, this one, pi over 3j squared minus 3 over 2j squared. Equal to 2 pi over 3j squared minus 3 over 2j squared. Okay. Now we have got the area for this guy. All we need to do now is take the full area minus off this one. Then we'll get back our answer for the area of shaded region. So area of shaded region, which look like this. The center, this area of shaded region will be equal to this thing, 2 pi over 3j squared. Will be equal to a full circle minus of this thing. So area of a full circle, we can use the formula pi r squared to find. Minus of this thing, we get from this part, which is 2 pi over 3j squared minus 3 over 2j squared. Become pi j squared minus of 2 pi over 3j squared plus 3 over 2j squared. Become pi over 3 j squared plus 3 over 2 j squared. So this is the area of the shaded region. So in conclusion, this question is not hard if we do it step by step. So recognize, let me repeat just one more time in case anyone is confused. So first, we recognize that we are unable to find the area from here directly. So we need to take one area of a full circle minus of the area of the part that's not shaded here. And then we recognize that we are unable to find the area of not shaded directly. And then we will split this into two parts, which is, I call this segment and I call this slice. This is the segment and this is the slice. And then I find the area of this thing and this thing separately. After, I can find the area of the slice and I can find the area for the segment. I add them up, I will get back this area. So I will be able to find the answer for this area of shaded region. Okay.